Morning student, welcome to our physics class. Last day what we learned, are you remember that one? Okay, I am telling. In simple machine we learn about the lever. Types of simple machine. How many types of simple machines are there? 6 types of simple machines are there. Lever, inclined plane, wedge, screw, pulley, wheel and axle. In between that, lever, already we learned about the lever. What is a lever? A lever is a rigid bar that can rotate freely about a point. A lever is a rigid bar that can rotate freely about a point. So, according to the relative positions of the load, effort and fulcrum, we classify the lever into classes. Class 1 lever, class 2 lever and class 3 lever. Which one is class 1 lever? When the fulcrum is in between the load and effort. Fulcrum is in between the load and effort. This type of lever is known as class 1 lever. And the example is beam balance, pair of scissors, crowbar, seesaw, etc. Okay. Next, class 2 lever. Lever of second order or class 2 lever. In lever of second order, the load is in between the fulcrum and the effort. The load is between the fulcrum and effort. In that case, we say the lever is second order lever. Class 2 lever or second order lever. The example of second order lever, wheelbarrow, nutcrackers, bottle opener, etc. And when the effort is in between the fulcrum and load, then the lever is known as class 3 lever. Like tongs, our forearm are the examples of class 3 lever. So now we solve some numericals or problems on this principle of lever. Example 1, what is that? An effort of 12 kg is applied on a machine of the movement of a load of 120 kilogram force. Find the mechanical advantage of the machine. How many loads is there? Load is 120 kg. So mechanical advantage is equal to load by effort. We know that one. So mechanical advantage equal to 120 kilogram force by 12 kilogram force. That means 10. Mechanical advantage is a ratio. So there will be no unit. Next, example 2. The length of a lever is 3 meter. The figure is given where the load is in between the fulcrum and effort. So this is the second order lever. Calculate the mechanical advantage of the lever if its fulcrum is situated at a distance of 120 cm from the load. The length of the lever is 3 meters. So we change it into centimeter. What to do? By multiplying 100, we change it into centimeter. So it is 300 centimeter. Length of the load arm is 120 centimeter. So length of the effort arm is total length of the lever, because from fulcrum to the effort is the effort arm. So it is 300 centimeter. So mechanical advantage is equal to length of the effort arm by the length of the load arm. So we get it 2.5. Next one, a man uses a 2.5 meter long crowbar to raise a load of 1000 Newton. Find a the effort needed to lift the load, and B, the mechanical advantage of the crowbar. The fulcrum is located at 2 meters from the effort end. So crowbar is a second order lever. So yes, is it? Crowbar is a second order lever or first order? Tell me. I am waiting for you. Crowbar is a first order lever, not second order lever or first class lever. That is why fulcrum is in between the load and effort. So we draw the figure. The fulcrum is in between the load and effort. Here the load is 1000 Newton, load arm is 2.5 meter minus 2 meter, which one is 0.5 meter. Okay. So effort is equal to what? Effort arm is 2 meter. So according to the principle of lever, effort into effort arm is equal to load into load arm. From here we can find out the effort is 250 Newton and mechanical load by effort is equal to 4. Today we learn about the inclined plane wedge. Next day again we will do some question answer of page number 60. Okay, in your book there is some question. Check your progress. We will do that question. What is an inclined plane? First you see that one. This is a platform. When I make the book like this way, this is an inclined plane. We can download from the truck by this inclined plane. Okay, so now we have to learn the definition of inclined plane. Okay, an inclined plane is a rigid sloping surface over which heavy loads can be raised or lowered to a certain height or depth. A wooden plank kept with one of its edge on a raised object and the other edge on the floor is an example of inclined plane. A heavy box needs to be loaded to a lorry. It is far easier to push it over an inclined plane than to lift it up. The amount of push depends on the weight of the load and the steepness of the slope. Steeper the inclined plane, greater will be the effort required. That means the inclination is how much we require less force, less effort. If it is steeper, inclination is not that much, then we require more effort. Okay, the mechanical advantage of an inclined plane is the ratio of the length of the plank inclined surface to the vertical height of the load raised. Mark it. So with the definition of inclined plane, you marked these lines also. What is the definition of inclined plane? Mark it. First bold word. An inclined plane is a rigid sloping surface over which the heavy loads can be raised or lowered to a certain height or depth. This one. Then you mark the mechanical advantage of an inclined plane is the ratio of the load to the plank inclined surface to the vertical height of the load raised. So the mechanical advantage of an, mark this one also, is greater than 1. Therefore an inclined plane acts as a force multiplier. This means that It can use to lift heavy loads with less effort. Ramps, mark it. Ramps, roads on hills, and staircase are all the example of inclined plane. Now we read about the wedge. Mark it. A wedge is a double inclined plane such that the two sloping surfaces taper to form a sharp edge. I am showing you. Chisels and axe. See that once. Two inclined planes are tapered to each other and make a surface. This is an example of wedge. Wedge is what? A wedge is a double inclined plane such that the two sloping surfaces taper to form a surf edge. The surf edge is used to cut, slice, or push things apart. A knife, an axe, and chisels are some examples of commonly used by us. Knife is, I show you the knife. See that once this sides is thicker. This sides of the knife is thinner. Two inclined planes are tapped like this way and make this surface very thinner to cut anything, to slice anything, or to push anything. Okay? In some cases, the number of inclined planes can be more than two. When there are more than two sloping surfaces, they generally taper to form a very pointed edge. Pins, nails, and needles are some example having pointed edge. We are using the needles, we are using the pins. So these are the pointed edge or pointed surfaces. Next we read about the screw. A screw, mark it. A screw is a cylindrical rod marked with winding spherical edge called thread. A screw looks like a nail with grooves cut spherically into it. A screw is actually an inclined plane wound around a rod. This is a screw. This is the pointed edge of the screw. Pointed edge. This is the head of the screw. Which one is splitted? See that one? Which one is splitted? Splitted. The tip of the screw is narrow, sharp, and pointed. You saw these ones? The tip of the screw is narrow. This is narrow, sharp, and pointed. The head has a narrow slit. I saw you, the head has a narrow slit. Here is a narrow slit. Which is used to turn the screw using a screwdriver. We use a screwdriver and we tighten it. As the screw is forced and rotated into a piece of wood, it travels a longer distance than a nail would. Less effort is needed to drive a screw into a block of wood than to drive a nail. Also, because of its thread, a screw grips the wood more firmly than a nail. So this is the we can better use a screw than a nail. Why? Because the principle of the screw also applies to a nut and bolt arrangement. And a screw jack used to lift a car, a long handle rotates the screw of a jack and the car is raised up. So these are the uses of screw. And why it is better than nail? Because as the screw is forced to rotate into a piece of wood, it travels longer distance than a nail. Less effort is required to drive a screw into a block of wood than a drive a nail. Also, because of its thread, a screw grips the wood more firmly than a nail. Okay, so today up to this, what new we are learned about the inclined plane, wedge and screw. Next class again we learn about the rest simple machines. Okay, bye.